Hi, thanks for joining me in this discussion on IFR conditions. This video is one of many on my YouTube channel that deals with the causes of IFR weather. In other videos, I have discussed how low ceilings cause IFR weather. Now we're going to look at low visibility. And in this video, we'll specifically focus on other obscuring phenomena.
We'll start out with mist and we'll work our way through these other topics. First, mist. By definition, mist is a visible aggregate of minute water particles suspended in the atmosphere that reduces visibility to less than 7 miles, but greater than or equal to 5/8 of a mile. So mist is different than fog in just the visibility. It's made of water droplets, though, just like fog. So basically, it's a fog that just reduces visibility a little bit. Fog is reported by an ATSC machine when the temperature dew point spread is 4 degrees Fahrenheit or less, so it's close to saturation, and the visibility is between 5/8 of a mile and 7 miles. Mist typically forms as a result of cloud condensation nuclei that are hygroscopic. They attract water vapor. So you can see mist even at relative humidities that are less than 100%, relative humidities that are somewhere between 85 and 95%. These are little water droplets that form. They don't grow very rapidly. They kind of stay small. So they more or less are kind of in a suspended state. They don't grow anymore because there's not any more water vapor available. So they don't get bigger. So you can think of mist as droplets that really want to be fog droplets. Haze is different than mist. Haze, by definition, from the glossary or from the Federal Meteorological Handbook number 1, is a suspension in the air of extremely small, dry particles. Key word is dry. Dry particles that are invisible to the naked eye and sufficiently numerous to give the air an opalescent appearance. Opalescent means milky. So in other words, these are anything else in the air. I mean, dry particles, aerosols, combustion particles. Pollution basically is haze. So haze is usually the worst when there's a strong inversion that prevents the atmosphere from mixing out, meaning that the lower layers kind of combining with the upper level layers to kind of distribute all the pollution and dust and all the other things. And you can see the haze layer really well at altitude if you're looking for this as you climb. Required conditions for haze, of course, typically light winds. Stronger winds tend to mix things out a little bit. A strong temperature inversion, usually implied by subsidence in a high pressure system, usually create the worst haze conditions. Haze is reported by an ATSC machine when the temperature and dew point spread are greater than 4 degrees Fahrenheit. That's kind of significant. If it's greater than 4 degrees Fahrenheit, means that it's dry. The air is not close to saturation. You're not going to get water particles. It's going to be mostly just aerosols. And the visibility between 5/8 of a mile to 7 miles. You'll find haze at low altitudes because typically the surface of the earth is where all the aerosols are coming from. And it can produce significant backscatter, especially when the sun is behind you and low on the horizon, whether it be sunrise or sunset. Haze can kill. People think that haze is just something that's kind of annoying, but there was an accident in 1999 where a Piper Saratoga crashed over Long Island Sound, killing John F. Kennedy Jr., and that was attributed to spatial disorientation as a result of the sun low on the horizon and the reduced visibilities down to about 3 to 4 miles. Typically, you'll find haze in industrial areas because that's a good source of aerosols.
Haze may reduce visibility so much that VFR flight may not be possible. And if you do depart and try and maintain VFR into deteriorating MVFR or even IFR conditions, spatial disorientation may result. This is what happened to JFK Jr. When he left New Jersey flying to Martha's Vineyard in the summer of 1999 across Long Island Sound. Visibility was reduced. It was MVFR visibilities of 3 to 5 miles, but trying to fly VFR, it was very difficult, especially as the sun started to set. So remember that haze can cause problems with VFR flight.
Another phenomenon that will reduce your visibility is smoke. By definition, it's the suspension in the air of small particles produced by combustion. And of course, where there's smoke, there's fire. So fire can be produced by either industry, in other words, pollution, basically large chemical factories or factories in industrialized areas, or forest fires. Forest fires can dramatically reduce visibility over a large region. Also, if the winds are very light or no wind, the smoke tends to be denser. When you have stronger winds, it tends to mix it out. And also, if you have high pressure systems, those induce inversions, which tend to cause the air to stagnate. So the required conditions, you need a strong temperature inversion to have really reduced visibilities as a result of smoke because of the mixing. And the characteristics of smoke depend upon the combustion source, where's the fire, also the strength of the wind and the inversion. We've kind of been talking about these things through the last few slides. The source of combustion, if it's a forest fire, tends to be widespread. Every summer, it seems like here in North Dakota, visibility is reduced because of forest fires in Saskatchewan or someplace else in Canada. Or it could be localized as a result of industries. So these are places like Butte, Montana, sits in a valley, and they have paper mills there, and they tend to reduce the visibility significantly. Also, strong winds means that it'll mix out the smoke. Weak winds tend to make the smoke more localized and denser. The visibility is more or less. It's decreased quite a bit. And then also the strength of the inversion. And remember, the inversions allow for mixing out of the pollutants, and if you have a strong inversion, it'll keep it trapped.
Smoke is reported only at augmented ASOS stations. In other words, there needs to be a human weather observer that can actually put into the ASOS report or the METAR that there is smoke in the area. Non-augmented ASOS and AWAS weather systems cannot report smoke. There needs to be a human being. It needs to be augmented for smoke to be reported in a METAR. The weather machines will instead report haze. Remember that haze is an observation of dry particles in the atmosphere. Smoke is a dry particle. But to distinguish between smoke and haze, a human is required to make that observation. Here is a picture that I took when I departed Grand Forks on my way to Minneapolis. This is when there were forest fires or brush fires in Canada, and in North Dakota we had reduced visibilities. At the time that I departed, the visibility was 1 mile, and the stations that I was flying above at this time were also reporting IFR conditions. You can see that the visibility is better aloft, but of course it is much worse below. So sometimes you can get on top of the smoke and get into the clear air. On this particular day, I think I was flying at about 9,000 feet.
Blowing dust, sand, snow, or spray also can reduce visibility significantly. And we call any of these phenomena blowing when they are higher than 6 feet in the air. If it's less than 6 feet, then typically we call it drifting, like drifting snow, drifting sand, or drifting dust. Here's the difference between dust and sand. Dust is fine particles of earth or other matter that's raised or suspended in the air by wind. Spray is an ensemble of water droplets torn from the wind. So this happens at coastal areas where you have strong wind. that little water droplets will be carried up into the air. And typically, required conditions for any kind of blowing phenomena is strong winds. Winds typically more than 25 knots, and also a loose surface. Tends to be a low-level phenomena. If it's higher than 50 feet, then they'll start calling it storms, like sandstorms or dust storms. Once again, backscatter is a concern with any of these blowing phenomena, especially blowing snow. If you've driven in North Dakota or Minnesota in the wintertime, you're probably familiar with the reduced visibility as a result of the backscatter. And the only thing that's reported by the ATSC machine would be blowing snow. All the other phenomena have to be reported by an augmented station. But there is an algorithm for blowing snow. You don't need to memorize it, but when the visibility is less than 7 miles and the temperature is less than 14 and the ceiling is more than 10,000 feet and the winds are more than 22 knots, they'll call it blowing snow. And just for good measure, I thought I'd throw in the definition of blizzard. It's when winds are greater than 30 knots and visibility is less than 1/4 of a mile for more than 3 hours over a given location. And there used to be an additional requirement of the temperature being less than 20 degrees Fahrenheit, but that was dropped years ago. Dust storms, as I mentioned, are severe weather conditions where you have strong winds and dust over an extensive area, typically to a height of greater than 50 feet. And sometimes dust storms can reduce visibility significantly and dust can be found at high altitudes. This picture was taken by a friend who's flying a 727 years ago at altitude of 20,000 feet over Arizona, and you can see the dust storm. And then precipitation can reduce visibility. Here are the definitions of drizzle and rain. Drizzle is just small droplets that are very close together. Rain is bigger droplets that are more spaced apart. Rain is bigger drops, bigger than drizzle. Showers are precipitation that starts and stops with rapid intensity or starts and stops very quickly. You can have snow showers, rain showers, a lot of different kinds of showers. And of course, you have better visibility with precipitation than you do with dust and rain and fog. And the reason precipitation gives you better visibility is because the particles are bigger. And there's fewer of them also. And you know that the intensity of drizzle and also of snow is determined not by the intensity of which snow is coming down, but based on visibility. And of course, as precipitation occurs, cloud base will lower. That is the end of this PowerPoint on other obscuring weather phenomena.